historic test of the new ion drive technology, which could eventually slash greenhouse gas emissions from aviation. Ever since Orville and Wilbur Wright's momentous flight in the winter of 1903, aircraft have been driven by propellers or jets that must burn fuel to create the thrust and lift needed for sustained flight. A team of experts from the Massachusetts Institute of Technology managed to unlock a process known as electroaerodynamics, previously never seen as a plausible way to power an aircraft. They were able to fly the new plane, with a wingspan of 5 meters, 16 feet, a distance of 55 meters, 181 feet, at a speed of 17 kilometers per hour, 10.6 miles per hour. That's hardly supersonic, but the implications of this unprecedented mode of flight could be stratospheric. The future of flight shouldn't be things like propellers and turbines, said Stephen Barrett, who designed the prototype.
It dates back until at least the 1920s, where a eccentric inventor at the time started experimenting with high voltage electrodes and thought he had discovered anti-gravity, which of course was not the case, but that set some of the initial groundwork on mechanisms for creating what's called an ionic wind in the atmosphere by having high voltage electrodes ionizing air and then accelerating the ionized air.
At first glance, the plane itself doesn't look light years away from other renewable aircraft, such as the Solar Impact 2 craft that in 2015-16 used energy from the sun to fly around the world. Unlike Solar Impact, Barrett's plane doesn't have any propellers or solar panels, or any movable parts whatsoever. It is a solid-state aircraft. Instead of engines, it is powered by a system comprising two main sections. At the front of the plane sit a series of parallel electrodes made up of lightweight wires that produce an enormous charge of plus 20,000 volts, supercharging the air around it and splitting away negatively charged nitrogen ions. At the plane's rear are rows of airfoils set to minus 20,000 volts. The ions automatically move from a positive to negative charge, dragging with them air particles that create the so-called ionic wind to provide the aircraft with lift. The technology to create ionic wind has been around since the 1960s, but it was previously thought nowhere near efficient enough to prove useful to aeronautics. The team not only showed that it was possible for ion-driven craft to fly but also, due to the relative lack of drag created by the electrodes, predicted that efficiency would increase in lockstep with speed, potentially opening the way for bigger, faster planes in future. It's clearly very early days, but the team at MIT have done something we never previously knew was possible, in using accelerated ionized gas to propel an aircraft, said Guy Grattan, aerospace engineer and visiting professor at Cranfield University, who was not involved in the study. Barrett said he believed the current prototype could be scaled up a significant amount but cautioned that there may be a limit to how much propulsion the technique can produce. "We don't yet know if there is such a limit and we will certainly try to scale up as much as possible," he said. "I don't yet know if you'll see our vehicle carrying people anytime soon, but obviously I'd be very excited if that was the case." He said the technology could be used on the skin of commercial aircraft, reducing drag and therefore the energy needed to power modern passenger jets. This would be much more efficient than the current situation where you have concentrated engines that generate thrust, which have to fight against a large passive airframe that generates